Welcome everybody to the MAC 1105 Test 1 Review Workshop. And I am going to be covering, my name's Noah Schmidt. I'm a math specialist in the Learning Commons, and I'm going to be leading this workshop. It's just basically going to be a workshop where we cover about 17 problems that will in all likelihood, some form of those that material will be on your test, your Unit 1 test for MAC 1105. So this is hopefully going to give you a good review before you take your Unit 1 test. So let's start with problem 1. Problem 1 states, determine the equation of the line in the graph shown below. Put the equation in slope-intercept form, if appropriate, giving your slopes and intercepts as integers or reduced fractions. First off, the slope-intercept form of a line is y equals mx plus b. M represents the slope, b represents the y-intercept. And when you look at this particular graph, you can determine from looking at the graph what the slope is and what the y-intercept is. You can see that the line is crossing the y-axis at 6. And so because it's crossing the y-axis at 6, we're going to plug 6 in for our b. And then to determine the slope, you just need to determine the rise over the run between any 2 points. If I take this point right here, and this point right here, -2, 0, if I go up 3, so that would be a rise of 3. And then if I run +1, then I've basically got a slope of 3 over 1, which is just 3. So 3 can be substituted in for your m. And so your equation of the line would be y equals 3x plus 6 would be your equation of the line. As you're watching this recording, I would recommend stopping the recording to try some of these problems on your own before we go over them together. Problem 2 states, determine the equation of the line in the graph shown below. Put the equation in slope-intercept form if appropriate, giving your slopes and intercepts as integers or reduced fractions. So what we have in this particular problem is a horizontal line. Now the horizontal line is basically, a horizontal line is in the form of y equals some number. So that's all. It's not necessarily in the form of y equals mx plus b. It's in the form of y equals a constant. Now you can see that the horizontal line here is always crossing the, or is always on -2 for your y coordinates. Every y coordinate is -2. So you're going to say y equals -2 would be your equation of the line there. If you had a vertical line, the way to determine a vertical line, equation of a vertical line, is it's always in the form of x equals some number. If we move on to question 3 says, for the following graph, determine whether the graph is symmetrical with respect to the x-axis, the y-axis, the origin, or none of these. More than one answer may be correct. So for the x-axis, you want to determine, here's our x-axis right here. We want to determine if we reflect the graph over the x-axis, would the graph be the same? See, if I reflect this top piece over the x-axis, it's going to be kind of facing down right here, which wouldn't be the same graph. If I take my bottom piece and I reflect it over the x-axis, it's going to be facing up on the left side, and it would not be the same graph. So we're going to say, no, it's not symmetrical with respect to the x-axis. The y-axis, though, if we reflect over the y-axis, we basically are going to do the same thing, but we're reflecting over the y-axis. So here's our y-axis running vertically. If I reflect this top piece over the y-axis, again, it's not going to be the same graph. If I reflect the bottom piece over the y-axis, it's not going to be the same graph. So we'll say no, the graph is not symmetrical with respect to the y-axis. For the origin would be, we would need to determine symmetry with respect to the origin, we need to reflect the graph over the x-axis and the y-axis and determine if we have the same graph. If I take this top piece of the graph and reflect it over the y-axis or the x-axis, it's right here. And then if I reflect it over the y-axis, all of a sudden it's right on the same graph. It's going to form the same graph. And if I take the bottom piece and reflect it over the x-axis, it's facing up this direction. And then if I then reflect it over or flip it over the y-axis, it's going to give us the same exact graph. So if we're determining whether it's symmetrical with respect to the origin, we're going to say, yes, this graph is symmetrical with respect to the origin. Number 4, the graph of h of x equals square root of x is shown at the right. We're going to graph k of x equals 2 times the square root of x. And we're going to plot at least 3 points. Now, to plot our points, I basically selected 3 numbers to plug in for x. I selected 0, 1, and 4 to plug in for x. If I plug in 0 for x, I'd have 2 times the square root of 0, and the square root of 0 is 0, so 2 times 0 gives us 0, so the y-coordinate would be 0. If I substitute 1 in for x, then I would have 2 times the square root of 1. The square root of 1 is 1. 2 times 1 gives us 2, so there's 2 for our y-coordinate. And then 4 for x. If we plug in 4 for x, we'd have square root of 4, which is 2. 2 times 2 is 4. And so 4 would be the y-coordinate. So our 3 ordered pairs are 0, 0, 1, 2, and 4, 4. Here's 0, 0, here's 1, 2, here's 4, 4, and there's our graph. Then we just can draw the graph through the points. And so that's called a function transformation. Number 5, this is a polynomial equation. We've got the equation 2y squared minus y equals 8y cubed. What I did first is I needed to get every single term onto the same side so it's all set equal to 0. But I wanted to leave my leading coefficient as a positive number. So I wanted 8y cubed to say positive. So the first step was to subtract 2y squared from each side and then add y to each side to move it all to the right side. And so it's all going to be set equal to 0. So you have 8y cubed minus 2y squared plus y. Then we have to factor this and set our factors equal to 0. Now the first step in factoring is to factor out y as your greatest common factor. Because you have y cubed, y squared, and y, you can factor out a y, and you're left with y times parentheses 8y squared minus 2y plus 1. Now then you want to try to factor the 8y squared minus 2y plus 1 further, but there are no 2 binomials that are going to, by trial and error, we would not be able to determine any 2 binomials that would FOIL to give us this original polynomial. So this cannot be factored any further, but we do have a solution. Because we have a y, we have y equals 0. Now you could try to solve this, set this polynomial inside the parentheses equal to 0 and use the quadratic formula or completing the square, but that's not something you would have learned yet. So our only solution in this particular problem is going to be y equals 0. The next problem states, find the distance between the points -4, 0 and 0, -2. Give an exact answer. So we don't want to get a decimal for our answer. We want an exact answer, and we're going to simplify any radicals. Now, the distance formula is d equals the square root of parentheses x1 minus x2 squared plus parentheses y1 minus y2 squared. Now, we want to plug our x1, y1, and our x2, y2 in for those numbers. And you have d equals square root of parentheses. Instead of x1, we put -4 minus, instead of x2, we put 0 squared plus parentheses. Instead of y1, we put 0 minus, instead of y2, we put -2 squared. And then we need to simplify this. So -4 minus 0 is -4. So it ends up being square root of -4 squared. -4 is in parentheses, plus 2 squared. And then your -4 squared would be 16. So you'd have d equals the square root of 16 plus 2 squared is 4. So 16 plus 4 gives us 20. So it would be the square root of 20 would be your result. But you have to try to simplify that to lowest terms. And so you're going to do that, you have to simplify the radical. You make two new square roots. The first square root should contain the largest perfect square that'll factor into 20. And that would be square root of 4. So it'd be 4. Or would be 2. Square root of 4 would be 2. And then 4 times 5 would give you 20. And so then you'd have square root of 5 in your other radical. So it'd be 2 square root of 5 would be your final answer for the distance between the 2 points on this particular problem. The next problem states, find the midpoint of the line segment from 2, -7 to 3, 5. The midpoint has a different formula. Midpoint formula is different from the distance formula. Here's the midpoint formula right here. M equals parentheses x1 plus x2 over 2, comma, y1 plus y2 over 2. So again, like the previous problem, I let x1, y1 be one of my points and x2, y2 be the other point, and we're just going to plug these numbers in. So you have m equals parentheses x1, which is 2, plus x2, which is 3, all over 2, comma, y1, which is -7, plus y2, which is 5, over 2. 2 plus 3 is 5 over 2, so that just becomes 5 halves. -7 plus 5 is -2 over 2 is -1. So 5 halves, comma, -1 is your result here. So now our next problem is, given that f of x is x squared minus x and g of x is 2x plus 8, find g of f of x. Make sure you fully simplify your answer. So this is what we call a function composition. A function composition is where a function is a function. Another function is the input variable of a second function. So you have g of f of x. F of x would be the input variable or the independent variable for g of x, is what this function composition is. So to find this function composition g of f of x, we want to substitute f of x into the input variable for g of x. So you'd have g of x is 2x plus 8. We would plug x squared minus x in for x. So it would be 2, and instead of x, we would have x squared minus x plus 8. but you have to fully simplify the answer. So we're going to take the 2 and distribute it into the parentheses, which would give us 2x squared minus 2x plus 8 as our final result there. So the next problem says 3x squared plus 81 equals 0. So this is going to be a little bit different. We want to solve for x. So the first step that I showed here was to subtract 81 from each side to move it over. You'd end up with 3x squared equals negative 81. And then you would end up dividing by 3 on each side, which would give you x squared equals negative 27. But then you square root each side, and when you square root each side, you end up with plus or minus square root of negative 27. Because the square root property states that the way you want to cancel out a square is by square rooting each side. But when you take the square root of negative 27, we're only interested in real solutions here. We haven't learned how to do complex how to determine complex numbers yet. And so there's no real solutions when you take a square root of a negative number. So that's our answer that we're going to put for this particular problem, is no real solutions. The second problem, 4t squared minus 72 equals 0, we'll do the same thing for our first step. We'll move the negative 72 over by adding 72 to each side. That leaves us with 4t squared equals 72. And then we'll divide by 4 on each side to get the t squared by itself. You'd have t squared equals 18. And again, to cancel our square out, we want to square root each side, which leaves us with t equals plus or minus square root of 18. But square root of 18 can be broken down further or simplified further. So we make 2 new radicals. 9 is the largest perfect square that'll factor into 18, and 9 times 2 is 18. But the square root of 9 is 3, so 3 square root of 2 is what square root of 18 simplifies to. But since we had a plus or minus, one of our solutions is 3 square root of 2, and another solution is negative 3 square root of 2. And so those are our 2 solutions for this particular problem. The next question says, solve the equation for x. We have y equals 2x minus 9 over 5x plus 7. First, since y is just itself, we can put y over 1, and that leaves us with a proportion. And the way to solve a proportion is to cross multiply and set your cross products equal to each other. And so when we multiply 1 by 2x minus 9, we get 2x minus 9 equals, then the y needs to distribute to both terms. So 5x times y is 5xy, and y times 7 is 7y. So we have 5x plus y, 5xy plus 7y on our right side. Since we're solving for x, our next task is to get everything that has an x in it onto one side and everything term that has an x that does not have an x in it onto the other side. So the first thing that I did there is I subtracted 5x from each side, which cancels the 5x here. And so you have 2x minus 5xy minus 9 equals 7y plus 9. But then negative 9 doesn't have an x in it, so we need to add 9 to each side to move it over. And so you have 2x minus 5xy equals 7y plus 9. But x is a is the greatest common factor between the two terms. So we can factor out x as a greatest common factor, and what's left over is 2 minus 5y. And since x is multiplied by 2 minus 5y, we can now divide by 2 minus 5y on each side to cancel it out there, and we have x by itself. So this ends up being x equals 7y plus 9 over 2 minus 5y as our final result there. So number 11 says write the equation of the circle centered at 1/8 with radius 9/10. Now, standard form of a circle is x minus h squared plus y minus k squared in parentheses equals r squared. R is the radius and hk is your center. HK is your center. So we already have the center to be 1/8. We'll label 1 h and k as 8. The radius is 9/10, so we need r squared to be plugged into the formula. So we're going to square 9/10 to get r squared. So 9/10 squared is 9 squared, which is 81, over 10 squared, which is 100. So 81 over 100 gets substituted in for r squared. And then 1 gets substituted in for h, and 8 gets substituted in for k, and you have x minus 1 squared plus y minus 8 squared equals 81 over 100. Number 12 says, give the equation of a circle with a diameter that has endpoints -8, -6, and -6, +8. This is another distance formula problem. Now, if we have a circle that has 2 points that are endpoints of a diameter of the diameter of the circle, then we need to find the midpoint between those 2 points to find the center of the circle. Because the center of the circle is halfway between the endpoints of the diameter. So we're going to use the midpoint formula between the 2 points. One of your points is x1, y1. The other point is x2, y2. And we just substitute the numbers in. So hk is going to be x1, which is -8, plus x2, which is -6, over 2, comma, then y1, which is -6, plus y2, which is +8, over 2. And then we just simplify that out. -8 plus -6 is -14, over 2 is -7. And then -6 plus 8 is 2, over 2 is 1. So -7, 1 is your center. And then there's 2 options for finding the radius. You can either find the distance between the center and either one of your endpoints, or you can find the distance between the endpoints of the diameter and divide it by 2, because half of the diameter is the radius. I chose the second option. I found the distance between -8 and -8, -6, and -6, 8, and then I'm just going to divide that by 2, and I'll have my radius. So here's how I set it up. R equals the square root of parentheses x1, which is -8, minus x2, which is -6, which changes the signs to positives there, squared, plus y1, which is -6, minus y2, which is +8, squared. And then this is all over 2, because we're taking half of the radius, half of the diameter to get the radius. -8 plus 6 is -2, which ends up being squared. So you have square root of -2 squared plus -8 -6 minus 8 is -14. -14 ends up being squared. So -2 square root of -2 squared plus -14 squared all over 2. -2 squared is 4, so this is the square root of 4 plus -14 squared is 196, all over 2. 4 plus 196 is 200. This ends up being square root of 200 over 2. So that is your r, but we need r squared to plug into the formula. So r squared is just taking square root of 200 over 2 and squaring it. Square root of 200 over 2 squared, the square root of 200 squared is just 200, because when you square a square root, it just gets rid of the square root and you just have the number that's inside the square root by itself. So it'd be 200. And then over 2 squared is 4. But 200 over 4 is 50. So 50 is r squared. So we just substitute into the circle formula. 50 is r squared. And then h is -7. And k is +1. So what we end up with is parentheses x minus -7 squared, but that ends up being +7 because of the two minuses become positive. Subtracting a negative is like adding a positive. That's squared. So x plus 7 squared plus parentheses y minus 1, 1 is your k, squared equals 50. So that would be your equation of the standard form equation of the circle on this problem. Number 13, what is the radius of a circle that is centered at -2, -5 if it is tangent to the y-axis? So we are given that a circle is centered at -2, -5. So I went ahead and plotted -2, -5 right here. And what this means when it states that the center is that the circle is tangent to the y-axis means that the circle is intersecting the y-axis at one point. So the only way that's possible is if the circle is just looking like this, where it just touches the y-axis right here at 0, -5, and then it just kind of turns and never goes beyond that point, because if you go beyond that point, you'd be intersecting at more than one point on the y-axis, as I'm demonstrating. If this circle was any farther beyond, it would be, and it had that same center, it would then be not. It'd have to intersect the y-axis at more than one point. So it has to look like this. So really the distance, as you can see by my cursor, is really just the distance from the center of the circle to the y-axis, and which is just 2. So you can see that the distance from the center to the y-axis is 2, which is going to be the radius for this particular circle. Number 14, what is meant by the domain of a function? And then when is the domain of a function all real numbers? Now, the domain of a function is all possible x values of the function. So all the values that x could potentially be in the function is the domain of the function. The domain would be all real numbers when there are no restrictions on x. So if x can just be any number, then you're not going to have any x's that would make the function. The function's going to be defined at all x points. So if you plugged any x's into the function, they would all return a real number. You wouldn't have any x's that would cause the function to be undefined. So that's pretty much what I stated. Simple definition was just when x has no restrictions, then its domain is all real numbers. Number 15, give the domain of n of x equals square root of 13 minus x in interval notation. What is the 0 of this function? Well, basically, what we want to understand here is there are going to be restrictions on x for this particular problem because we have a square root. So a square root can never be a negative number, or you don't or it's not going to return a real number. So whatever 13 minus x is, it has to be greater than or equal to 0. So that's what I did, is I set 13 minus x greater than or equal to 0 and solve for x. And then once you solve that inequality for x, then you'll know what x would have to be so that you don't have an undefined number inside the square root. You wouldn't want to have a negative number inside the square root. So 13 minus x is greater than or equal to 0. We add x to each side, and we end up with 13 is greater than or equal to x. So x must be less than or equal to 13, or the function would be undefined. So when we make our domain is going to be going, our x's are going to go from parentheses negative infinity to 13. And since we have an equal sign under the inequality, then we have a bracket for the 13 because x could equal 13. So it's negative infinity to 13 with a bracket would be the domain. The 0 of the function, I'll write this out, is just basically whenever the y coordinate is 0, then whatever x is when the y coordinate is 0 is the 0 of the function. So if I put 0 in for n of x, I'd have 0 equals 13 minus x, or square root of 13 minus x. And I wanted to then solve for x. Really, to cancel out a square root, I would square each side. And so that would get rid of the square root, and you would have 13 minus x equals 0, because 0 squared on the left side is just 0. So then we would just want to solve for x, so we would add x to each side to cancel the negative x out. And you'd have x equals positive 13 as your final result for your 0. So the 0 is just x equals 13. Okay. The next problem says, give the domain of k of x equals 5 minus 2x over 5x squared minus 8x minus 21 using interval notation. And then what is the 0 of this function? There is going to be a restriction on what x can be because we have a fraction. And so if there are any x's that produce a 0 on the denominator of the fraction, then those x's are not cannot be a part of the domain. So to determine what those x's are, we're going to set our denominator equal to 0. So we'll set 5x squared minus 8x minus 21 equal to 0. So we'll set this equal to 0, and then we'll just factor it and set our factors equal to 0 to solve it. So I make two parentheses. I don't have a greatest common factor I can factor out, so I make two parentheses. The first terms in each parentheses have to multiply to give you 5x squared. So one of your terms is 5x, the other is x. So, and then the n numbers have to multiply to give you negative 21, but they don't necessarily add to give you negative 8 because we have the 5 in front of the x. So whatever we put for our n numbers, it has to FOIL to give us this original polynomial. Now what I chose was positive 7 next to the 5 and negative 3 next to the x. And the reason for that is because when I multiply my outer terms, 5x times negative 3 is negative 15x. And the inner term, 7 times x is 7x. Then negative 15x plus 7x would be negative 8x, which would equal the middle term. So this is the correct factorization. Now we want to set our factors equal to 0. So we'll set 5x plus 7 equal to 0. And we'll set x minus 3 equal to 0. And we'll solve for x. So the first step in 5x plus 7 equals 0 is to subtract 7 from each side to cancel the 7 out. You'd get 5x equals negative 7. Then to cancel the 5 out that's in front of the x, we would divide by 5 on each side. and we would have x equals, or x cannot equal -7/5. And then you'd have x minus 3 equals 0. You would add 3 to each side, which would give you that x cannot be 3. So our domain cannot include -7/5 and cannot include 3. So we're going to make 3 different intervals that are joined with unions. So our domain is going to go from -infinity to -7/5 with a parentheses so we don't include the -7/5 union. Then we're going to go from -7/5 to 3 with parentheses for both so we don't include the -7/5 or the 3 union, then parentheses 3 so we don't include the 3 to infinity. And so those are our 3 intervals that are joined together with unions. To find the 0, though, we want to set the numerator equal to 0, because the 0 is basically whatever x value makes the y coordinate equal to 0. So if I put a 0 for k of x, then whatever x value would make this entire fraction be 0 would be the 0 of the function. The only x value that would accomplish that is whatever would make the numerator 0. The denominator can never be 0 or the function's undefined. So we just need to set 5 minus 2x for our numerator equal to 0 and solve for x. So we do that. We have 5 minus 2x equals 0. Then we add 2x to each side, and we get 5 equals 2x. And then to cancel the 2 out that's in front of x, we divide by 2 on each side, and you get x equals 5/2. So that would be the 0 of the function. And our last problem states, or our next to last problem states, there's actually 18 problems on this particular review. How do you find the zeros of a function from a graph? How are they related to the x-intercepts? The zeros of the function can be found if you have the graph in front of you, then find where the function crosses the x-axis. So wherever the function crosses the x-axis would be the zeros of a function. And then how are they related to the x-intercepts? The x-intercepts are basically the zeros of the function written as ordered pairs, which are in the form of x, 0. So the y-coordinate is 0 for the x-intercept. The zeros just have to be written as x equals the number. So that's the difference between the zeros and the intercepts, is the intercepts, x-intercepts are written as in ordered pair form, and the zeros are not. The last problem states that the graph of y equals p of x is given below. Answer each of the following questions from below the graph. A, what is the domain of p of x? Give your answer using interval notation. So we have the graph, and the domain is basically found by looking at the farthest right that the graph goes to the farthest left, or farthest left that the graph goes to the farthest right that the graph goes. That's assuming there's no jumps in the graph or periods where the graph is not continuous, but there's none of that here. You just, if you look, the farthest left that the graph goes is negative, or starts as -infinity, and it ends at 14, and 14 is included. So our interval for the domain is from -infinity, 14 with a bracket. The question B states, what is the range of p of x? And we're going to give our answer using interval notation. The range is basically the farthest down that the graph goes to the farthest up that the graph goes, assuming there's no discontinuity in the graph or asymptotes. And there are none. You see that the graph, the farthest down that the graph goes is -4. It starts at -4, and it's touching on -4. So we're going to include -4 for our y coordinate. And it goes on up to infinity. So -4 with a bracket to infinity with a parenthesis would be the range of the graph. C says, what are the intercepts of P of X? Give your answers in coordinate form or ordered pairs. So the x-intercepts are where the graph crosses the x-axis, and you want to write those as ordered pairs. So the graph crosses the x-axis right here at 0, 0. It's also crossing the x-axis right here at 9, 0. And it's also crossing the x-axis right here at 13, 0. And then the zeros of P of X are just where it's crossing the x-axis, written as just x equals the number. So it's crossing the x-axis at 0, x equals 0, 9, and 13. So you just would say for the zeros, x equals 0, 9, 13. E says P of 11 equals some number. Well, the number P of 11 is basically the y coordinate when x is 11. If you go to 11 on the x-axis, that would place you right here. Then the y coordinate at that point is 2. So 11, 2 is the y coordinate at that particular x. So 2 would be P of 11. G states, for what values of x does P of x equal -3? If you go to -3 on the y-axis, you see that when the y coordinate is -3, the graph is here, and that particular x coordinate is 3. So 3 is one of those values, but you see that the y coordinate is also -3 right here. And the y coordinate at that point or the x coordinate at that point is 7. So 3 and 7 are the values of x that cause P of x to be -3. So that's pretty much all the problems that we're going to go over. So I hope you've enjoyed this review and that it's helped you review. And I wish you the best of luck on your Unit 1 test. And keep in mind to feel free to follow the procedures that we sent in an email to receive online tutoring from the Learning Commons as well. So anyway, I hope you guys have a great day. Thank you.